So hello everyone, thanks for coming in this very hot room. I'll try not to faint during my presentation, but if I do, I apologise in advance. So yeah, I'm Merve, and today I'll be talking about quantifying human behaviour using social media images. So technological devices are indispensable in our lives. Usage of such devices and the online services they're connecting us to, such as search engines and social media platforms, we're creating vast amount of data, capturing core aspects of our everyday lives. This data tends to be available at high speed and low cost, opening up precedented opportunities to analyze social processes as they unfold or measure human behavior at a global scale. But with the increased internet speed and connectivity, online posts have been shifted from being only text-based to visual media. So it's quite widespread for all of us to share pictures and videos on social media platforms such as Instagram and Flickr. And also, thanks to the advances in the computational power, we can analyze the content of these images much better, and also thanks to the state-of-the-art image analysis methods like Michael was talking about earlier on this stage, which is a great talk. So in my PhD, me with my supervisors Tabitha and Susie Moat, we investigate whether we can quantify human behavior using social media images from Instagram and Flickr. So I have various case studies under this topic. For example, can we track protest outbreaks around the world? Or can we predict noise complaints in New York City? But today, I'll be talking about estimating income across London and New York City. So income, as all the other socioeconomic variables, is something that is quite valuable for especially policymakers. And traditionally, this information has been drawn from surveys such as census. But running a survey at such a big scale is quite expensive, both time-wise and money-wise. And also, although it provides valuable and quite important information to us, there's a delay in reporting such data. So obvious benefits, therefore, lie in coming up with alternative sources that can complement those reliable traditional sources. So a group in the University of Stanford have come up with one potential solution. They use Google Street View images to estimate demographic and socioeconomic variables across the United States, the cities in the United States. They created an automatic tool to identify the motor vehicles and detect their age, model, and make. And then they extracted information on age, race, income, as well as the political tendency, who the people from that neighborhood are going to vote in the presidential elections. So this is quite promising. And we were thinking, are there any other alternative sources out there that we can use? So we thought, can we estimate income using photographs shared online? So there's a recent trend among online users lately that is to share pictures of food. So be honest, how many of you have shared a picture of food on social media or sent it to a friend? Be honest. So according to a food survey conducted by one of the leading supermarkets in the UK, in 2016, 1 out of 5 Britons has shared a picture of their food on a social media channel or via a messaging app. So this trend, maybe thankfully, is creating vast amount of data online. So we were thinking, well, can we actually make some use of these pictures related to food? Can we use them to estimate income? So for this, we focused on a 6-month worth of data taken within London and uploaded to Instagram. First question, we need to come up with a way to basically identify the food pictures. Automatic way, we're not going to go through one by one by hand. So for this, we used a deep learning-based approach, which is using convolutional neural network. I'm going to just briefly talk about some technical details in the last 2 slides. So if you're not interested, you can sleep for only 2 slides. So again, regarding back to Mike's presentation. So if you have a CNN, you have 3 options. One, you can build it from scratch and train it from scratch using millions of annotated images. 2, you can use a pre-trained one and fine-tune it towards your needs. Or 3, you can again take a pre-trained one and use the output from some of the intermediate levels, mainly from fully connected layers, and use them as features to train a separate detector or classifier to your needs. So this is what we did. We took a pre-trained CNN that is trained on the ImageNet data set, and then, chopped the final layer off, got the output from the penultimate layer, and then trained a linear SVM to identify whether a picture is food-related or not. And for the training set, we extracted images from Bing Image Search. I'm happy to discuss details after the talk, but I have to move on because of the time. So great, so we extracted food pictures from Instagram, but we have to find a way to extract a bit more information. We have to come up with a good representation so we can actually model income estimates. So for that, and this is the accuracy of our, basically the performance of our classifier in the test set, which performs around 95% of accuracy. So yeah, we have to come up with a good representation so we can actually model income. And for that, we again use the same network trained on ImageNet, but instead of chopping any layers, we use the whole network and extracted the output as our, what I would keep calling feature vector, which is a 1,000-dimensional vector of 1,000 categories, and we have score for each category. Because it's a softmax layer, the score indicates how likely or how related an image is to that category. So if you basically look at like the first example, the first 3 categories are espresso, coffee mug, cup, which are the one with the highest scores, and the bottom 3 are the one with the lowest scores. So we treated them as our features per image. Okay, so we have food pictures. We managed to create some representations per picture. Another decision we need to make is at what level we're going to estimate income. So for this, we picked MSOAs in London. So MSOAs, all you need to know, are population areas with 2,000 to 6,000 households. And we were trying to estimate median household income per MSOA. So what we did, we gathered all the pictures taken within that MSOA and created one mean feature vector by taking the mean of the scores per category. And then we built an elastic net model. And we fit a model by leaving one MSOA out. And then using that fitted model, we tried to estimate the income for the MSOA. And then we repeated the same thing for all of the 983 MSOAs. And we added up a set of estimated income values. So to basically understand how good we're doing, how good our model is doing, we compare these estimated income with the actual household income. So it turns out there's a significant correlation between 2 sets of values, but the model is only able to capture 9% of the variance in the income. Not bad, but not good either. So we were thinking, well, okay, it's good to focus on the food-related pictures, but we have a data set which is from 6 months worth of Instagram data in London, which is around 6 million pictures, and the food pictures are only 12% of that data set. So why not make use of the entire data set? So we repeated the same analysis using the entire set of pictures in the Instagram data set we have. So this is a visualization of our results. On the left-hand side, with the blue frame, they're the actual income values per MSOA, and on the right-hand side is our estimates. So our model is able to capture some high-income patterns around central London, like north of the Thames, around Westminster area, if you can see. There's certain similarities, and around like Richmond area. Yeah. So to have a better understanding of how each one of those categories actually contribute in the final calculation of the income, let's have a look at the coefficients of the elastic net. Sorry, and this is the statistics. You don't need to. No. So we go. So it's the top 10 highest positive and top 10 highest negative coefficients of the elastic net. So all you need to know is what this visualization suggests is if an image has a higher score for categories like patio, plate, and espresso, it's more likely that it's taken from a higher income area, and vice versa for one of the categories from the red. Okay, so it's kind of like suggesting something, but is it always the case? Again, like I'm going to refer to like Mike's presentation. He was also like showing it's quite easy to like fool the neural nets. So we picked a set of test pictures and ran our CNN and extracted the category with the highest score. And let's see some examples. So on the right-hand side, we have 3 categories from the red group, highly positive ones. So it's espresso, park bench, and plate. And it looks like CNN is doing an OK job in labeling and identifying what's going on in the image. But if you look on the left-hand side, so there are the 3 categories from the blue group from the previous picture. It seems like it's mislabeling the images. But if you look closely, there's a certain pattern going on. It's labeling the first set of images as cowboy hat. Yes, it's not a cowboy hat, but there's some sort of hat that people are wearing. Or the comic book. It's not a comic book, obviously, but it's like a graffiti. It's some sort of drawing. So what I'm trying to say is, yes, it might be mislabeling, but it's still able to capture similarities, but as well as identifying differences between categories to a certain extent. But all I'm trying to say is we have to be cautious in interpreting these labels because they might not be representing what we are actually hoping or thinking that they're representing. So the features that we were using were extracted by using a CNN trained on ImageNet. But to get a good scene understanding, we need a better holistic scene representation. So we used 2 more CNNs, one trained on Places database, and the other one's trained on Sun Attribute database, to extract another set of features. And we built other elastic net models using them. And afterwards, we basically mixed the features, we combined them, and created other models as well. So it turns out that the best performing model among these 7 models we generated is the one where we combined features extracted by using CNN trained on ImageNet and on Places. And also, before moving on, I want to say the models that use single set of features perform worse than models that we created using a set of combined features, which kind of makes sense because each set of features is trying to characterize different aspects of the image. One is more, like ImageNet, for example, is more focused on the objects that's in the image, whereas Places or Sun Attribute is more focusing on the scene. So it seems like Instagram images are doing OK on the London dataset. But is it true for all the other metropolitans? So we decided to try it also on the New York City. So for New York City, everything else is the same, apart from the spatial units, because MSOAs are just in the UK, as far as I know. So for spatial units in the US, in New York City, we picked census tracts. And again, all you need to know is census tracts are population areas with 4,000 households on average. So we tried exactly the same thing, and we created, again, 7 different models. And in this case, ImageNet Places model, as well as the combined one, which combines feature sets from all 3 CNNs I was mentioning, ImageNet, Places, and Sun Attributes, are performing the best compared to the other models. So, some take-home messages from me. So our findings suggest that pictures shared online can give us some insights into the household income in metropolitans such as London or New York City. And models using combined set of features are more powerful compared to the models using single set of features. And also, we need to be cautious when interpreting the category scores. We can't for sure link a certain category to, say, higher income areas or certain categories to lower income areas. So our results are in line with our initial hypothesis that online images can give us insights into socioeconomic variables such as income. And these findings, together with the other findings I found from the other projects in my PhD, highlight the potential of online images as a source of cheap and rapidly available measurements of human behaviour around the world. Thank you.